Welcome to the presentation of this research paper. The title is Under Frequency Load Shedding in Mongolia, Simulation Assessment Considering Inertia Scenarios. The authors of these papers are Choidorj Adiyabazar. He is with the National Dispatch Center in Ulaanbaatar, Mongolia. Marta Noemi Acosta from Universidad Autónoma de Nuevo León, Mexico, and also with the University of Southeastern Norway. Professor José Luis Rueda and Professor Peter Palensky, both of them with the Delft University of Technology, Netherlands, and who is speaking now, Professor Francisco Gonzalez-Longatt. Okay, the presentation scheme will be very simple, a short introduction. Then we will discuss about the Mongolian power system and the under frequency load shedding schemes in Mongolia, then simulation scenarios, and finally conclusions. Okay, let's start this presentation with a very short introduction. Okay, as you must be aware, Mongolia is a very beautiful country and is located in the middle of Asia, basically between Russia and China. Russia at the north, and is interconnected to the central energy system of Mongolia, and China at the south. Okay, the Mongolian power system has been changing very rapidly in the recent times. Right now, by 2020, Mongolia have a renewable capacity installed of 20% and is expected to increase to 30% by 2030. Okay, at the moment, the transmission system of Mongolia is very heavily loaded, especially during summer, winter. Okay, and because the power system is working to the limits, it's susceptible to any under frequency event. Okay, one example of one very important under frequency events is the major event on the 9th of June 2018. Here on the right hand side, you can see this is the frequency plot. You can see that around 23 hours on 29th of June 2018, there is a sudden loss of generation and the frequency dropped from 50 hertz until 48.47 hertz. Okay, of course, because this big under frequency event, the under frequency load shedding was activated, and then the frequency reached until 49.99 49.77 when the frequency finally recovered. This is a classical example of an under frequency event in Mongolia. What is the idea of this scientific paper today? Well, today we are planning to assess the under frequency load shedding scheme in the Mongolian power system. What is the idea? To provide the transmission system operator in Mongolia, the National Dispatching Center in Mongolia, with inside information about what is happening in the case of under frequency load event. Okay, as I say before, we are investigating here, considering the major event that can happen in the Mongolian power system, and that is the major loss of infeed coming from Russia. Okay, this paper is the first assessment of this type, and also is providing very good insight, because we identified that during summer, that summer is the low inertia scenario in Mongolia. We can detect frequency instability in the Mongolian power system if the interconnection between Russia and Mongolia is tripped when the power transfer is 250 megawatts. But let's jump into important information. the electrical power system in Mongolia is basically a 5-area system, okay? Some of those areas are disconnected each other. Here in the central area of Mongolia, where the capital city is located, this is the central energy system of Mongolia. Then we have the Western energy system, the Eastern energy system, we have the Southeastern energy system, and here we have the Altai energy system, okay? What is important that you need to know is that Ulaanbaatar city is the most important load inside the Mongolian power system and is interconnected to Russia. The whole Mongolian power system is basically 85% coming generation from coal-fired power plants, okay? And probably between 15 to 20% of the total generation is coming from renewables. Today we are assessing is the under frequency load shedding in this system. As you can see, this is the central energy system, okay? The under frequency load shedding in Mongolia is quite simple. It's based on automatic conventional static under frequency load shedding using the classical under frequency relay ANSI-81. Okay, this is a decentralized scheme and is designed in order to cut down the power between 45 to 55% of the national demand. Okay, the 85% of the total load installed in the central energy system has under frequency relays. Okay, technologies used is quite modern, using some relays from ABB, Cells, and Siemens. Okay. Here in table number 2, you can see the classical settings that we can find at the under frequency relays in the central energy system. Okay. Well, here we define 2 different scenarios. The first scenario is what we call the winter peak. The winter peak is basically characterized because they are a massive power demand, okay? A lot of heating, a lot of people inside. As a consequence, we define this like the winter peak because the demand is the maximum, but because the demand is maximum, we need to have many generation units working, and as consequence, that is the high inertia scenario. On the other hand, we have the minimum inertia or low inertia scenario, and that is when we arrive to summer. In summer, many of the Mongolian people, they go to the countryside, they are holidays, they are very good weather, warm weather in Mongolia, and as consequence, the peak demand is reduced. Okay, in scenario number, we have 3 different cases, and we are considering 3 cases based on the time of the day, the peak demand, the total generation, and more important, what is the power in feed between Mongolia and Russia and Mongolia. Okay. Simulation results for the case number 1, for scenario number 1, high inertia system. And as you can see over here, if we think about the maximum, the case number 3, that we have the maximum power transfer of 250 megawatts from Russia to Mongolia, we can see over here that the minimum frequency is reaching 48.3 hertz, and after the under frequency load shedding intervene, we have that all 3 stages of the under frequency relay strips, and as consequence, the final steady state frequency is 48.83. However, the most important scenario is the low inertia scenario. The low inertia scenario, as I say, is the summer because people go to the countryside, the demand is reduced, many big generators are disconnected, especially CHP, and as a consequence, the inertia is quite reduced, okay? If you look over here, the simulation results for the case number 3, that is that importation of 200 megawatts from Russia to Mongolia, you can see in red color over here, we have a frequency instability, okay? As you can see over here, we have at the very beginning the event, the frequency tried to recover, but at the end, you can see over here, around 35 seconds after the disturbance, the system has not enough power to keep the balance, and as a consequence, the system is unstable, okay? Well, it's time to close this presentation with few conclusions. We are very proud about this scientific paper because we evaluate and assess the under-frequency load shedding scheme in Mongolia. The under-frequency load shedding scheme in Mongolia is the classical traditional under-frequency load shedding that is decentralized with local measurements and decision, okay? We identified that the summer represent the low inertia scenario, and when the importation from Russia to Mongolia is 250 megawatts, we can have some problems, okay? We are working toward to solving those problems. However, they are very good news. The Mongolian power system is moving toward low carbon generation, including many installations coming from wind power and PV systems. And as consequence, we are expecting more inertia reduction in the Mongolian power system. However, the good news is Mongolia have installed already 29 phasor measurement units. And we are taking the opportunity or taking the advantages of implementing a wide area measurement system in order to enable a wide area under frequency load shedding, okay? In couple papers, we will make more advances to the TSO in Mongolia, offering the optimal under frequency load shedding settings, and also proposing a wide area measurement system and protection system for under frequency. Well, thank you for watching this presentation about the under frequency load shedding in Mongolia, this simulation assessment considering inertia scenarios. Choidorj Adiyabazar from the National Dispatch Center in Mongolia, Marta Noemi Acosta from Universidad Autónoma de Nuevo León, Mexico, and University of Southeastern Norway, Professor José Luis Rueda and Professor Palensky from Delft University, and myself, Professor Francisco Gonzalez. We would like to say thank you very much for watching this presentation. It's been a pleasure being here, and we are opening right now the session for question and answers. Thank you very much.